Well, good afternoon. It is section 4.4, simplifying fractions. What I want you to do is go ahead and hit pause and copy down this information. So go ahead and do that. Well, simplest form is when the greatest common factor of the numerator and denominator is 1. And I know when we worked on greatest common factor, we talked about this in class of the uses of finding the greatest common factor, and this is where we will be using it. So when we look down a little bit further where it says equivalent fractions, these are when fractions that have the same value. Okay, and that is ultimately what simplifying is. It's not changing the value of the original fraction. It's just making it smaller with equivalency so that it is more easily used, especially when we multiply and divide, even when we add and subtract as well. It's not changing the value of it. That's one thing you need to remember the importance of, is that it's not changing the value. It's just simply making the fraction itself, that ratio, a little bit smaller and a little more manageable. So again, when we're looking at this, for an example, is pizzas. Okay, and we'll assume they're the same size. And this this pizza has 8 slices according to the denominator. This one has 2 slices. And when we look at shading in 4 out of the 8, okay, then we see that we have this amount that is shaded. And this is 1 out of the 2 that is shaded. So when we do this, you can see now that the two fractions are equivalent. Okay, there's the same ratio. This is half of the pizza, this is half of the pizza. Okay, so let's look at this first problem. And it's simply saying replace each space with a number so the fractions are equivalent. Well, one thing that you always need to do is always start with the fraction that's completed itself. If you start there and go in the other direction, okay, we are then trying to, since the denominators are complete, how did 7 become 21? And since it's getting larger, that is going to be multiplying. So if we're multiplying by what to get 7 times what to give me 21, that would be 3. So we're going to multiply the numerator by 3, and we get 5 times 3 equaling 15. That is an equivalent fraction. Okay, so let's try the next one, and I'll let you go ahead and hit pause and solve. Now for this problem, again, we're starting with the completed fraction and going towards the one that we're trying to find. And since it is going from 18 to 6, we are getting smaller. Therefore, we would have to divide, and 18 divided by, you can say 18 divided by 6 will give you this answer, which is 3. So we're going to divide this by 3 as well, and we get 8 for an answer. So 6/8 would be my new fraction that is equivalent to 18/24. Okay? So let's look at the next one. Go ahead and hit pause and solve. Okay, now again, we're starting with the fraction that's complete, so it's going to be this one on the right, working our way to the left. And we say, well, 35 becomes 7. How? Well, divided by 5. So 20 divided by 5 equals 4. Okay. Now some of you might be looking at this and say, well, 7 times 5 gives me 35, so what times 5 gives me 20? That is another way of doing it, and if that works better for you, feel free to do that as well. The only issue that you're going to run into is if we throw a decimal point in here or on this side, then you're not going to be able to know exactly how many times 7 goes into 35 if it were 7.1, for example. You wouldn't know that answer, so then you would have to certainly take this number and divide it by this to get this number, so that this number then could be divided by 20 to get the numerator on up above. So again, we will eventually get into throwing some decimals into this. That is why I'm teaching you in this format to always work from what's completed to the other fraction to keep yourself from making that possible mistake and getting in that situation. So once again, always start with the fraction that's complete, go in the other direction, because once we put a decimal point in this, you would not be able to solve it saying, well, 7.1 times what gives me 35. It'd be a little more difficult to do. Okay, you could do it, it's just not as easily accomplished. Now we're just simply writing these in simplest form. So now we're, again, trying to find our greatest common factor to be able to reduce this fraction till its simplest form. So go ahead and hit pause and solve. So when I look at this, my greatest common factor that we're going to divide by is going to be 6. So 18 divided by 6 is 3, and 24 divided by 6 is 4. Now, if you did not find the greatest common factor and you simply found a common factor, that works as well. It's just that you're going to end up having to divide more than once. So if we say, well, these are both even numbers, so we'll divide both of them by 2, we'll get 9/12. Well, these numbers still have a common factor that can be reduced by, which is 3. So then 9 divided by 3 is 3, and 12 divided by 3 is 4. We still get the same result. However, we had to divide twice. Okay? And if you take this number that you divided by and this number that you divided by and multiply them together, you do get the greatest common factor of 6. Okay? So basically it's taking that greatest common factor and breaking it down according to its factors. So 3/4 is your answer. I don't really care which way you use it or go about it. Obviously, greatest common factor is the best, but I do know that eventually you'll have some really large numbers to where it's going to be more difficult to find that greatest common factor. So a common factor to reduce it, then you could find the greatest common from there. So many times it works better. So go ahead and hit pause and solve this. All right, well, common factor for this is 3. And so we end up getting 7/8 for an answer. That was the only common factor, so therefore it was the greatest common. Now let's try letter C, 19/24. Hit pause and solve. Well, 19, as you know, is a prime number. So if 19 does not go into 24 equally, then it is in simplest form, and you can simply write SF, and it is in simplest form. Let's take a look at our next one. Go ahead and solve this. Well, these are larger numbers, and if you're not sure what the greatest common factor is, if we know that they're even numbers, then let's do that first. And so 16 divided by 2 is 8, and 120 divided by 2 would give me 60. They're still even numbers, and you can reassess. There might be a number that's larger that would work for them as well, but if you're not sure, again, you can always divide by that even number of 2. So then we get 4 and 30, and we see that they're still even numbers, and so we can divide those by 2, and you see that you get 2/15, and 2 is a prime number if 2 doesn't go into 15 equally, and it does not, then we have our final answer. So if we take the 2's and multiply them together, you see that you get 8. So the greatest common factor for this would have been 8. Now many of you might have seen very easily from the very beginning that 4 goes into 16 and 4 goes into that 120. So then you might have got up to this point to 4/30 and then had to reduce it by 2. Okay, So there's lots of different configurations you could have went about this. Dividing by 4 first, dividing by 2 first, and then dividing that number by 4. Lots of possibilities. But again, your answer to this is 2/15. Greatest common factor was 8, which you don't have to know, but it's certainly useful. If you did divide by 8 at first, you would immediately got 2/15. And let's look at our last one. Go ahead and hit pause and solve this. Well, I look at my factors of 28, which are 4 and 7, and 7 goes into 77, so we'll divide that by 7, and we get 4, and then 77 divided by 7 is 11, and that 11 is prime, so 4 doesn't go into 11, so therefore we are finished. So 4/11 is your answer. Again, if you have any questions or concerns, please jot those down in your notes, and please bring those up in class tomorrow. Many of you do a great job of that, and please always get those higher level thinking questions that you pose in class, taking it that step further. So really pleased to see that. Have a great evening, and we will see you tomorrow.